Hello guys, welcome to our video of the playlist called C# for beginners. Okay, so let's start with something that's probably crashed on you at some point in this series, even if we didn't call it out directly. Let's say we are representing a person's middle name, but not everyone has the actual middle name, right? So let me write middle name equals null, right? String middle name equals null is something genuinely no value at all, and then we try to check its length. So let's run. As you can see, it's null reference exception, right? Probably the single most common crash in all of C#. This entire lesson is about handling situations where a value might genuinely be missing safely without your program blowing up. Let's dig in. Let's start with something worth understanding first. Remember, way back in the basic type lesson, we covered values like int, double, boolean. Here's the thing about those normally, they can never be null. Let me show you. Int age equal null. As you can see, it's showing a compile time error. This genuinely won't even compile. And int always has to have some actual numeric value. It can't represent nothing. But sometimes that's actually a real problem. Imagine a form filled for age that has not been filled in yet, right? 0 is not right, since that would mean the person actually claimed it to be 0 years old. So we genuinely need a way to present no value provided at all. That's what nullable value type solve. Let me show you. Int question mark age equals null, right? That question mark right after the type is the key here. It turns a regular int into a nullable int, meaning it can now hold either a real number or null representing no value. So let's print this. And as you can see, this actually compiles fine, and printing it just shows nothing since there is no value. And of course you can still assign it a real number 25, and whenever we actually have the one, right? And let me show you one example also. Int score equals null if score dot has value console dot writeLine score dot value, else console dot writeLine no score recorded. And to safety check whether a nullable value type has actually something in it, dot has value gives us true or false. If it does, dot that value grabs the actual underlying number. That question mark, int question mark, double question mark, or boolean question mark turns any value type into one that can actually represent nothing at all, which is genuinely essential for things like optional form fields or database columns that might legitimately be empty. Okay, so now we can have null values. We need convenient ways to actually deal with them, yeah? Let's say we have a nullable age, and if it's null, we want fall back to some default value instead. Let me show you. Int age nullable, and it's null, and int actual age, right? If age dot has value actual age equal age dot value, else actual age equals 0. Console dot writeLine actual age, right? This works, but it's genuinely a lot of code just to say use this value or fail back to default if it's missing, right? So let's see the output, and as you can see, it's printing out 0. This how can I say, this exact pattern, use this unless it's null, then use that instead, comes up so often that C# gives us a dedicated shortcut for this. Let me show you that shortcut. Maybe int h2 equal null and int actual age equal h2 right line actual h2 actual age, right? Okay. Int actual age equals h2 question mark and question mark 0. The double question mark is the null-coalescing operation. It reads as use h2, but if h is null, use 0 instead. One line replacing the whole if-else block from before. I got that. I think we use this kind of operations instead of if-else blocks in the flow control section. If you got that idea at that time, I think it's very easy to for you to understand. Let's see the output, and as you can see, it's 0. And if the value, let me show another example. For example, with h3, int h3 equal maybe 30, but nullable, and int actual age equals h3 0 console.writeLine actual age. And if the value actually exists like here, it just uses that real value, completely ignoring the fallback. Let me show you. It's 30. Why? Because it's not null here. Yes. And actually this kind of things works with strings too. Let me show you. For example, we have a string username equals null and string display name equals username guest console dot writeLine display name, right? And this works with any type that can be null, not just nullable value types, a string also included, genuinely useful for things like showing guest when a username has not been set. Let's see the output. It's showing a guest, right? The null-coalescing operation double question mark is your go-to shortcut for use this value or fallback to default if it's missing. So it's gonna help you to eliminate using the if-else block with just shortcuts. Yes, worth knowing feature. Now, this next part covers something that genuinely confused people at first because it changed relatively recently in C#'s history. So far, we've talked about value types being nullable with that question mark, but what about reference types, strings, classes, all the objects we've been building this whole series? Historically, those could always be null, no question mark required at all. As you can see, this one also, string username equals null without any question mark, right? This genuinely compiles without any error. Strings and reference types in general have always been allowed to be null. But here's the problem. That's exactly how we got that crash back in our cold open. The compiler never warned us, never helped us catch it ahead of time. So more recent versions of C# introduced something called nullable reference types as a genuinely safety feature. Let me show you. Nullable enable. Oops. Nullable enable string name2 equal null. Right. That hashtag nullable enable directive at the top of the file turns on a strict mode. With this active, the compiler now actually warns you if you try assigning null to a regular string, since without a question mark, you are telling the compiler this should be never null, okay? And string, maybe nullable name equal null. As you can see, there is no compiler warning as we see in the first example, right? But if you genuinely want a string that's allowed to be null, same idea as before, just add the question mark, string question mark, and now the compiler understands that's intentional, right? With nullable reference types turned out, a plain string is a promise. This will never be null, and string question mark is explicitly saying this genuinely might be null. Handle it carefully. Many modern project templates actually have this enabled by default now, which is honestly a really good habit formatting feature for beginners, since the compiler starts catching potential null crashes before you even run the program, right? Okay, now let's go back to our very first crash from the cold open and actually fix it properly this time. String middle name equals null, right? And same crash as before, trying to access dot length on something that's null, right? Int length equals middle age dot length. Length. Right. Okay. Console. Right plan length. Right. Int question mark length equals middle name question marks dot length, right? That question mark right before the dot is null conditional operation. It reads as if middle name is not null, go ahead and then get its length. But if it's null, don't even attempt it. Just give me a null back instead of safely, right? And chaining these kind of objects, let me show the example for that. For example, class address, we have address, maybe we have public string city, get and set, class person, public address, home address, get set. And here person p equal new person, string city equals person, not person, it's p dot home address dot city, right? And let's print this. Okay. And this genuinely shines with objects persons.home address question mark dot city. If home address itself is null, we never even attempt to reach it into for city. The whole chain just safely short circuits to null instead of crashing on a null home address. Let me show you example. Okay, as you can see, it's just returning null value. Why? Because our city is just null. The null conditional operator question mark before the dot is how you safely access something that might be null without needing a full if check every single time. Genuinely one of the most useful small features in a modern C#. Okay, last one for today, and this genuinely a more advanced situational tool, but worth knowing it exists. Sometimes you know that with certainty that something won't actually be null, yes, at particular point, even though the compiler can't quite prove that on its own. So let me show example. What I mean is first we're gonna call the nullable enable and string maybe get user name, maybe return Alex, right? And then here string possibly null name equals get username, right? And here the get username is marked as returning nullable string question mark, even though in this specific case, we know it always returns a real value. The compiler still warns us if we try using it directly, since it can't know that for certainty just by looking at the method signature. Okay, so int length, for example, equal possibly null name dot length. As you can see, compiler is warning us. Let's read the reference of a possibly null reference. Why? Because compiler already knows the possibly null name is kind of null type, so it does not know just that we are returning the Alex, that it's not null, but because we already marked it, it can be null. So compiler have no idea if it can be kind of not null or something like that. So it's showing us the warning, right? And what we can do in that situation is we can do put this sign. I think int length equals and possibly null name exclamation mark, yes, exclamation mark dot length. That single exclamation mark is the null forgiving operator. It's telling us, it's telling the compiler, I know this looks like it could be null, but trust me, I verified it, it won't be. Stop warning me about this specific line, okay? And let's see the output. Length, right? As you can see, it's 4 because length of the Alex is 4. And one important warning I want to give you is with exclamation mark string actually null equals null, right? And here's the most important caveat: the null forgiving operator does not actually protect you from a crash. It only silences the compiler's warning. If you are wrong and the value genuinely is null at runtime, it crashes exactly same as if you'd never used it all. So genuinely only reach for this when you are truly 100% certain based on the logic the compiler just can't see. Never use it as a lazy way to just make warnings disappear. Okay, what I mean is here, for example, let's return here null. We can return null, and we are saying here to compiler, don't worry, it can't be null. And let's see the output. And as you can see, it's just returning null reference exception because we are returning null, and we are telling the compiler that don't worry, it definitely be not null because we are 100% sure, but actually we are not. So use this exclamation mark after you check it and you are 100% certain about the situation or the value of that variable that you are checking. Okay, the null forgiving operator, a single exclamation mark, is a way to tell the compiler, trust me, but it's on you to actually be right, since it provides zero runtime safety, only silences the warning. Okay, all right, let's tie today's tools together with a realistic example: processing a user's profile where several fields are genuinely optional. Let me show you something like that. Maybe we're gonna have class of user profile, public string name get and set, public string middle name get set, public int age get set age. And then we're gonna have maybe class address, public string city get set, and maybe this kind of value, default value, int age, public address, nullable home address get and set. And then user profile user equals new user profile, name Alex, middle name equal null, and age equal null, and then home address null. Okay. User profile name is required, so it's a plain string. Middle name, age, and home address are all genuinely optional, so each one is nullable, right? And maybe we're gonna show display age. Int display age equals user dot age 0, right? And console dot writeLine age display age. Null-Coalescing for age fallback to 0, or really we could show not provided instead of if you want to, okay? And maybe middle name length int middle equals user dot middle name length console dot writeLine middle name length middle name length null. Okay, null-conditional for the middle name is length combined with null-coalescing like right after it to show 0 instead of nothing at all if it's missing, right? And then maybe string of the city and user dot home address dot string city, and here string also should be nullable. Then console dot writeLine maybe city city not oops. Okay, and then not provided. And some combination for the city safely reads through home address, which might be itself be null, and fallback to a friendly message if there is nothing there. Okay, so let's run all of them and see the output. And as you can see, age is 0, middle name length 0, city not provided. Nullable types, null-coalescing, and null-conditional all working together to handle a realistic object where several pieces of data are genuinely optional, right? Without a single crash and without a giant pile of if checks either, right? So that's for all today's lesson, and your challenge would be maybe creating a class representing a book with a required title and a nullable int for page count, since maybe you don't know it yet, right? And write a code that safely prints the page count or unknown if it's null using the null-coalescing operator. So today we covered nullable value types with a question mark syntax, the null-coalescing operator for fallback defaults, nullable reference types, and what changed with modern C# with null-conditional operator for safety reaching into things that might be null, and finish it with the null-forgiving operator for those rare cases where you are certain but the compiler is not. Honestly, null handling is one of those things that separates code that crashes unpredictably in production from code that gracefully handles missing data. Genuinely worth having these tools comfortable in your toolkit. Next time we are moving into pattern matching, some really elegant ways to check and work with data based on its shape. Okay, see you there. Take care.